Good morning and welcome to the second lesson of engineering mechanics. Earlier we have seen what engineering mechanics deals with, and also we have seen three fundamental quantities: mass, length and time. We also saw that when we measure mass in kilograms, length in meters and time in seconds, we call it SI units. We'll continue with that, and we'll see what derived quantities are, what are their units. These derived quantities are quantities that we use in engineering mechanics, both in statics and in dynamics, that we are going to see later. Okay, we'll begin with the first fundamental quantity, that is length, and see what are some quantities which may be derived from it. This length we usually represent by symbol X or symbol S or symbol L, okay, or when we mean a vector quantity, we also represent by an arrow on the head. Whatever be the symbol, its unit will be in meters or kilometers or centimeters and so on and so forth. Once we identify that, one derived quantity which we may say area, which we represent by symbol A, is proportional to x square, and so it has unit meter square. Similarly, volume we represent by symbol V often, and which is proportional to x cube, and hence it has units meter cube. These we already know, but however we'll come back and see these when we try to compute areas and volumes of complex shapes using theorem of Pappus, sometime when we deal with center of gravity, centroid and so on and so forth. Another quantity of interest to us is area moment of inertia, which we represent by symbol IXX or IYY and so on, which is proportional to x to the power of 4, and hence it has units meter to the power of 4. Okay, having seen these, let us try to see how we can combine one or more of fundamental quantities to form new derived quantities. Let us say we are trying to combine length, whose symbol is X or S or L, with units meters, and we have duration, which we represent by symbol T, whose units could be either in seconds or hours. One quantity which we may define is velocity. Velocity is distance covered per unit time, which we represent by dx over dt, and hence it has units either meters per second or kilometers per hour, depending on the units we use for length and depending on the units we use for duration. And we also know a unit conversion factor 5 by 18 meters per second is 1 kilometer per hour. Another quantity of interest which is immediately derived from velocity is acceleration, which is the second derivative of displacement or length, and units of this typically are meter per second square. You might already be familiar with the acceleration due to gravity, 9.81 meters per second square. A third quantity which we may define, which we may call jerk, is the third derivative of length, and its units will be meter per second cube. In fact, we can also use a third quantity, that is mass. We have seen earlier in this, we have combined length and duration. We may also throw in mass as one of the quantities, fundamental quantities, and define a few other derived quantities. We can define momentum, which is equal to mass times velocity, which we say mass is represented by m, velocity is represented by v, and so this h is equal to m times v. Mass has units kilograms and velocity has units meter per second. So the unit for momentum is kg meters per second. Okay, this dash here needs to be understood as multiplication and not a minus sign. So we read it as kg meters per second and not kg minus meter per second. Another quantity that we can immediately define is rate of momentum. That is how fast or how slow momentum is changing. This we can define as derivative of momentum. Okay, momentum is mass times velocity, so rate of momentum is derivative of mv. Okay, we have momentum units of this quantity mv as kg meters per second, and we are dividing by another time duration dt. So the units of this momentum will be kg meters per second and dividing by another second, and so kg meters per second square. This rate of momentum is an important quantity in dynamics. It's important because according to Newton's laws, it is proportional to the external force acting on it. In fact, we may use this definition to define what is a force, and hence this force has units kg meters per second square. This unit comes in so often both in statics and dynamics that it is given a name, and the name given is Newton. Okay, and we often abbreviate it as N. Okay, so we have force whose units are N, or you may also write as kg meters per second square. This N is an abbreviation for kg meters per second square. Another quantity we may define is moment of a force, which we represent by symbol m. This will be equal to force multiplied by moment arm, because force has units newtons and length has units meters. It is Newton times meters. Okay, we may also note here that work done by a force when it moves an object over a distance f will also be f times the distance over it moves, and hence it also has units Newton meter. This Newton meter is abbreviated or given a name. Newton meter is given a name joule, which is abbreviated as J. So the work done have a units joules J. In addition to this, we may consider another derived unit which we call power, which is often represented by the symbol P, is work done per unit time. Okay, work done per unit time. Okay, or energy per unit time. Work we have seen is measured in joules and time in seconds. So this power P has units joules per second, and it is given a name watt and a symbol W. Okay, so units of power are watts. Okay, we have seen most of the derived units that we deal with in engineering mechanics, and so we'll kind of try to give a summary of what all we have seen, a quick glance of what all we have seen, and conclude this lecture. We have seen that three fundamental quantities that come directly from the three derived quantities that directly come from fundamental quantity length are area in meter square, volume meter cube, moment of inertia meter to the power of 4, and by combining length and duration you have velocity, acceleration and jerk with these units. In fact, we have also noted that unit conversion between one units of velocity to another unit are 5/18 meters per second is equal to 1 kilometer per hour. And we have seen the fundamental the derived quantity momentum, which is represented by symbol H, has kg meters per second square, and force has a unit kg meters per second square, and this kg meters per second square is given a name Newton, abbreviated as N. Similarly, moment or work done or energy, all of them have newtons, Newton meters, and this Newton meter is given a name joule, or abbreviated as symbol J. Power P has units Newton meter per second, and this unit is given a name watt, and W. With that, we conclude this lesson. I would strongly encourage you to remember these units, because we'll be dealing with them as we go through the course engineering mechanics. Thank you very much for staying. Have a good day.